Hello everyone. Now we have to discuss series and parallel connections of coupled circuits. First we have to discuss series connection. Later we will discuss parallel connection. In this series connection, first we have to discuss additive polarity. Additive polarity. What is the meaning of this additive polarity? Means current enters both the dots. That's it. If current enters both the dots, then it's said to be additive polarity, right? For this, the circuit first we have so like this. We are having the coil and we are providing the dots. This is one and this is two. See, from this the current enters the both the dots, right? Let us say this is current I. Okay, this is current I. Because these two coils are connected in series, therefore L1, L2. This is plus M, right? That's it. These two are connected in series, therefore I1 which is equals to I2 is equals to 1. For this, the electrical equivalent is taken one dependent source, then like this we have to write, right? This is L1, this is plus minus L2 plus minus, this is what? L1 L2, this is M dI2 by dt, this is M dI1 by dt. Across we have voltage plus minus the current through this is simply I. That's it. Okay, here I1 which is equals to I2 which is equals to I, because this is series connection. That's it. Now we can start the analysis. By KVL we can write V is equals to what? L1 dI1 by dt plus L2 di by dt. Sorry, this is M. Right, this is M completed. From loop 2, this is what? Or you can write, because all are connected in series, there are no separate equations. Plus what we are having, L2 into dI2 by dt plus M into dI1 by dt. That's it. So I1 is equals to I2 is equals to I, right? Then V which is equals to di by dt gets common. Now we are having L1 plus M plus L2 plus M, right? Which is equals to V which is equals to, you can write di by dt, you can write now it is L equivalent. L equivalent, right? L equivalent. This is in time domain. Therefore, to get frequency domain, what we have d by dt is nothing but j omega. So, v, which is nothing but j omega, small I is nothing but capital I. We are having L equivalent. That's it, right? This is in frequency domain. Or simply we can write, later we can write the summary. This is in frequency domain. That's it, right? Next, we have to discuss subtractive polarity. Subtractive polarity. Subtractive polarity means what? Current enters from one dot and leaves from another dot. That's it, right? For this, the dot convention is based on the subtractive polarity. Here the current enters from one dot and leaves from this dot, right? The current is same because I1 is equals to I2, which is equals to I clear. This is L1, this is L2. Then between these two we have what? M, right? For this, the electrical equivalent is we have L1 and we have dependent. So like again we have dependent source. Then we have what? Like this, right? This is the supply voltage and we have a current through this branch. This is L1. This is what? Minus plus, because we are having negative M, right? Negative M. This is L2. This is minus plus. Negative M, right? That's why this is what? If you provide negative place, now we can write M into di2 by dt, or if you provide plus minus, now you can write minus M di2 by dt. Okay, here M into di1 by dt. I think you got my point, right? For example, if you have plus minus here, now you can provide based on this minus M di2 by dt. Like this you have to write, okay? That's why here I am not providing plus minus and minus M di by dt. By default, here I can provide minus plus, for that M into di2 by dt. That's it, okay? So by KVL we have to write, by KVL V, which is equals to L1 di1 by dt. See, from this minus, right? Minus M di2 by dt, again plus L2 di2 by dt. We should provide plus minus, again here minus M di1 by dt. So from this we can write P, which is equal to di by dt gets common, therefore L1 plus L2 minus 2M into, that's it, di by dt completed, right? Now we can write this V, which is equals to L equivalent di by dt like that. V, this is small v, equals to L equivalent j omega into I. This is what? Time domain. This is frequency domain. So in that series additive polarity we are having L1 plus L2 plus 2m. In this subtractive polarity we are having L1 plus L2 minus 2m. Okay. Now we can write a summary. Here you can write additive polarity. Here we can write subtractive polarity, right? So here L equivalent is what? L1 plus L2 plus 2m. Here L equivalent is what? L1 plus L2 minus 2m. Here P, which is equals to L equivalent di by dt. Here also V, which is equals to L equivalent di by dt. Clear? Now V is equals to L equivalent j omega I. Here also V is equals to L equivalent j omega into I. So from this V by I we can write this Z, which is equals to L equivalent j omega L, like that. Z, which is equals to j omega L equivalent, right? This is the summary from this. This is first, this is second, this is time domain, this is frequency domain, time domain, frequency domain. That's it. Next we have to discuss parallel connection. In this case also we are having additive polarity. First we have to discuss with respect to additive polarity. For this the circuit, simple, you know the concept of series, right? Therefore this concept is very easy. Just we have to do mathematical analysis, that's it. So this is one coil, like that. This is another coil. So additive polarity means what? The current enters from the both the dots. Therefore this is one, this is second, that's it. So this is the main current, this is I1, this is I2, that's it, right? So between these two we are having mutual inductance. Let us provide self inductance, and this is L1, this is L2. Between these two we are having M, that's it. Clear? And next I1, I2 provided, then the supply voltage V1 AC quantity, that's it. Or we can say V only, not V1. From this we can write what is the electrical equivalent for this circuit. Simple, because this is coupled circuit, you can provide the electrical equivalent circuit for that. So this is coil, and now we have to provide that's it, right? Here we are having plus minus plus minus. This is, or you can write capital I or small I. Now here I am putting small I. This is I1, this is I2. Okay, there is no dot point. This is what? L1 di1 by dt, L2 di2 by dt. This is what? M di2 by dt. This is M di1 by dt. That's it, right? This is coupled circuit. This is electrical equivalent circuit. Now I is equals to I1 plus I2, right? From this first we have to write okay, L2 into di2 by dt plus M into di1 by dt minus, or you can provide KVL, which marker green, like this you have to consider. Okay, so based upon that, L2 into di2 by dt plus M into di1 by dt minus M into di2 by dt, see the current direction, plus L1 into di1 by dt. This is not plus, minus. Minus, right? See, this is plus minus plus minus. From this you can write KVL equation in this loop. So this is the equation which is equals to 0. Now di2 by dt, we have to common di2 by dt, that is L2 minus M, which is equals to di1 by dt. Now it is L1 minus M. That's it, right? So from this we can write di2 by dt, which is equals to L1 minus M by L2 minus M into di1 of t by dt, or you can write di1 by dt. That's it. Okay, yeah, we know that I is equals to I1 plus I2. I is equals to I1 plus I2. From this, di by dt, which is equals to what? di1 by dt plus di2 by dt. So from this we can common di1 by dt, 1 plus what we have? di2 by dt, di1 by dt, right? From this we are having like this. Yeah, di1 by dt gets common, therefore 1 plus di2 by dt by di1 by dt. So in place of di2 by dt, so from this di2 by dt by di1 by dt is nothing but what? From this, then we can substitute this equation to this, right? In place of di1 by dt, 1 plus di2 by dt by di1 by dt is nothing but what? L1 minus M by L2 plus M, right? Therefore di by dt, which is equals to di1 by dt, what we have? 1 plus L1 minus M by L2 minus M, right? So from this, which is equals to what? di1 by dt, we are having L2 minus M plus L1 minus M by L2 minus M. So what we are having? di1 by dt, which is equals to L1 plus L2 minus 2M by L2 minus M, right? This is, for example, 1. We know that V, which is equals to L1 into di1 by dt. You can consider any equation, M into di2 by dt. So from this, L1 plus M into, in case of di2 by dt minus di1 by dt, we can write L1 minus M by L2 minus M, right? This is what di by dt. Okay, so this is equation 2. Next, so in this equation 2 we have to substitute this. So this is di1, right? So from this you have to substitute this di1 from equation 1. Substitute di1 by dt in equation 2, right? Therefore equation 2 implies what we are having, simple manipulations, v which is equals to, we are having di by dt only, because we are substituting with respect to di1 by dt, therefore we are going to get di by dt, right? In this what we are having, L1 L2 minus L1 M plus M L1 minus M square by L2 minus M into L2 minus M by L1 plus L2 minus 2M. So this L2M gets cancelled, this L1M gets cancelled, therefore V by di by dt, which is nothing but what, L equivalent, right? L equivalent. Therefore from this additive polarity, L equivalent is what, L1 L2 minus M square by L1 plus L2 minus 2M, right? If you have any confusion, do your own analysis. Okay, Z equivalent is what, simple, at any case Z equivalent is what, like this. This is what, frequency domain. Okay, this is about what, additive polarity. Now we have to discuss subtractive polarity. Subtractive polarity means what? What is the circuit? Sorry. Subtractive polarity means what? Like this, we are having the coils. So in this dot at this place, another dot is at this place. That's it. This is I. This is I1. This is I2. So from coil 1, the current enters from the dot. From coil 2, the current leaves from the dot. That's it. So this is coupled circuit. For this, what is the electrical equivalent? Simple. For this, the electrical equivalent is what? Like this. Next, that's it. Here minus plus, it is plus minus, this is what, L1 di1 by dt, this is M di2 by dt, this is M di1 by dt, this is L2 di2 by dt. That's it, right? So this is the current I, or you can choose another color. This color, this is I1, this is I2. That's it. This is the electrical equivalent of this subtractive polarity coupled circuit. So same analysis from the previous case. You will do the same analysis from the previous case. From this, what we have, L2 into di2 by dt minus m di1 by dt plus m di2 by dt minus L1 di1 by dt, which is equals to 0. Based upon that KVL, we are having this, right? So from this, what we are having, we can common di2 by dt. Then we are having L2 plus m, which is equals to di1 by dt. Now we are having L1 plus m. That's it. From this, di2 by dt, which is equals to what? L1 plus m by L2 plus m into di1 by dt. We know that I is equals to I1 plus I2, that is di by dt, which is equals to di1 by dt plus di2 by dt. Clear? Therefore from this, di1 by dt gets common, 1 plus what we are having, L1 plus m by L2 plus m. Same analysis like before, right? Let us say this is 1. We all know that consider any one of the equation. Let us say P is equals to L1 into di1 by dt minus m into di2 by dt based upon the dot convention. From this, di1 by dt gets common. P is equals to L1 minus m into L1 plus m minus L2 plus m, right? And then what we are having, this is what di1 by dt. That's it. This is 2. From 1, we are substituting di1 by dt. That's it, right? Substitute di1 by dt in equation 2, same like before. Therefore equation 2 implies V, which is equals to di by dt, right? From this, what we are having, L1 L2 plus L1 m minus L1 m minus m square by L2 plus m into L2 plus m by L1 plus L2 plus 2m. From this, L2 plus m gets cancelled. Therefore V by di by dt, which is nothing but what, L equivalent, which is equals to what, L1 L2 minus m square by L1 plus L2 plus 2m. So this is the subtractive polarity, and we know that Z equivalent is what, always it is j omega L equivalent only, right? Now we have to write the summary. First one is what, additive. In this additive, what is the L equivalent? What is the L equivalent? L1 L2 minus m square by L1 plus L2 minus 2m, right? Second one, subtractive polarity. In this subtractive polarity, what we are having, L equivalent is what, L1 L2 minus m square by L1 plus L2 plus 2m. That's it. This is about series and parallel connection. Simple. Listen carefully. In case of series connection, we have additive polarity. What is additive polarity? Current enters from the both the ends. So this is the coupled circuit, this is the electrical equivalent. We all know that in series connection I1 is equals to I2 is equals to I. So based upon this KVL we are writing this equation, right? So from this V is equals to di by dt, because current is same in every branch, therefore this is L equivalent. Therefore in case of additive polarity, the L equivalent is what? L1 plus L2 plus 2m. Like that, in case of subtractive polarity means what? Current enters from one dot and leaves from another dot. Therefore we are having L1 plus L2 minus 2m. That's it. This is about time domain with respect to frequency domain. So this is about the summary. Then coming to parallel connection, see, additive means what? The current enters from the both the ends. This is the coupled circuit representation. Like that, this is what? Electrical equivalent circuit representation, right? So in this loop we are providing KVL equation. So based upon that, this is the equation, right? This is the voltage balance equation. So in this, di by dt gets common, di1 by dt gets common. So from this di2 by dt, which equals to some part of inductances into di1 by dt. So from this we all know that I is equals to I1 plus I2. Therefore di by dt is equals to summation of these two currents. So from this di1 by dt gets common. So based upon this, di2 by dt by di1 by dt is nothing but like this. We have to substitute this equation into this. So finally we got what? This is, right? Therefore take any one of the equation from this branch or from this branch. Here I am considering the first branch equation, that is V is equals to L1 into di1 by dt plus M into di2 by dt. Like that we got what? di1 by dt. Then substitute from this equation 1, we have to substitute this di1 by d2 into equation 2. Finally we are having what? V by di by dt, which is equals to what? L equivalent. Therefore in additive polarity we are having L equivalent of L1 L2 minus m square by L1 plus L2 minus 2m. So we are doing the same analysis for this subtractive polarity too. So with respect to that, what we are having L equivalent as what? L1 L2 minus m square by L1 L2 minus 2m. Like that, in case of subtractive polarity, we are having L1 L2 minus m square by L1 plus L2 plus 2m. This is about series and parallel connections of coupled circuits.